Hey there. Hoping my solution here helps you with this question that you submitted. So the diagonal of a rectangle is 60 centimeters long. If the length of the rectangle is 12 centimeters greater than the width, find the dimensions. All right, so I submitted a solution here. It's a little bit neater than if I had tried to write with my mouse. So I'll just kind of explain my way through it. Okay, so here we see I labeled my rectangle. My diagonal is 60. I use W to represent my width, and I use W plus 12 to represent the length, because in the question it states that our length is 12 centimeters greater than the width. Okay, so our length is represented by W plus 12. Now I notice here with the diagonal formed, we form a right triangle, so you could use the Pythagorean theorem to solve for W, and that's exactly what I'm going to do. All right, so on this right side, I used my A to represent my W, or my width, my B represented my length, and then my C represents my hypotenuse, or 60. All right, so I replaced A squared with W squared. I substituted a W in for A. For B, I substituted in the length, which is W plus 12 squared. And then for C, I substituted the hypotenuse, which is 60. All right, so W squared I brought down. W plus 12 squared, I could FOIL this. Okay, so first outer, inner, last. I'm not going to show the work there, but you would get W squared plus 24W plus 144 when you FOIL that. It's multiplying two binomials. And then 60 squared gives you 3,600. Okay, so this looks like it's going to form a quadratic equation. So let's go ahead and solve this and get a 0 on our other side so we can solve that quadratic. So I combine my like terms, W squared and W squared is 2W squared, and I subtracted 3,600 from both sides to get a 0 on the right side. You want to get 0 on one side of your quadratic so that you can solve it. All right, the next thing I did, I realized I could divide everything by 2, so I removed the GCF of 2, so I divided 2 and my greatest common factor of 2 on the outside of the parentheses. And then I factored what I had here. You could use the quadratic formula if you'd like, or you could just factor by looking for two numbers that multiply to negative 1,728 and add to be 12. Might take you a little while, but eventually you would come across 48 and negative 36 as your solutions. Those two numbers would add to be positive 12 and multiply to be negative 1,728. Right, so those are my two solutions. Now I would use the zero product property, and I have my width equaling 36 and also my width equaling negative 48. In the context of this question, you can't necessarily have a negative width, okay? We're talking about distance, which is always positive. So my width of 36 would be the number that I would use here. Okay, so that's where my width is coming from. And we know that the length is 12 more than the width. So if you see here, we would do 36 plus 12, and that's how I am getting my length. All right, hopefully this helped you out to understand this question a little better. A little bit of a process, but again, hopefully this was helpful.